Previously, we saw a simple explanation of R.A.G. Now it's time to build our own R.A.G system. R.A.G works by retrieving relevant information to the user's query and passing it to an LLM, along with the user's input prompt. By doing so, we're providing the LLM with context it can refer to. The retrieval can be of any type. You can search from the internet, fetch through APIs, perform SQL queries, or use vector search. Vector search is one of the popular R.A.G techniques currently being used. Here's the complete pipeline of how it works. We start by converting our documents into vector embeddings. These are numerical representations of text and store them in a vector database. This allows us to search for relevant chunks of information later. Now, when the user sends an input, it's converted to embeddings. These embeddings are used to perform vector search, and from the results, top K chunks are retrieved. These retrieved results are passed to the LLM along with the original input, and the generated response is sent back to the user. And that's our R.A.G system. Now it's time to code it. First, let's set up our development environment. Open your favorite code editor. I'll be using Visual Studio Code. Create a requirements.txt file and add all the necessary packages that you see on screen. Let's create a dedicated virtual environment for our project. If you're on Linux, follow the commands I'm running. Don't worry if you're using a different OS. I'll display the appropriate commands for your system. Now, let's activate our virtual environment and install the required packages. For this project, we'll be using OpenAI's GPT-4o Mini. Here's how to get your API key. Navigate to platform.openai.com, log in, or create an account. Click the settings icon and select API keys. Generate a new secret key, copy your API key, and paste it into your .env file. While our packages are installing, let's start coding. We'll begin by importing the necessary packages. We're using LangChain for this project, which is a powerful framework for building applications with large language models. We'll configure OpenAI's GPT-4o Mini as our base language model. Using the Wikipedia loader, we'll fetch data about Elon Musk, or any topic of your choice. We'll implement token text splitting to break down our data into manageable chunks, creating documents. To keep things efficient, we'll work with the top 3 documents. For vector storage, we'll use ChromaDB. It's perfect for storing our document embeddings. We'll pass both the documents and OpenAI's embedding model to create our vector store. Next, we'll set up a retriever that pulls relevant chunks based on user prompts. We're using LangChain's specialized R.A.G prompt templates here. We'll format our documents to extract just the page content, excluding embeddings. Then we'll create a chain that processes retrieved documents from the vector database, handles user questions, uses LangChain's R.A.G prompt template, leverages OpenAI's GPT-4o Mini, includes an output parser for clean results. Finally, we'll use the invoke function to run our chain and test it with queries about Elon Musk. Before we see the final output, let's examine what documents our system retrieves from the database. Notice how it intelligently selects relevant chunks based on our search query and synthesizes them into a coherent response. This system demonstrates the power of combining retrieval and generation for more accurate and context-aware AI responses.